is required to be done from your side. So, okay. Welcome everyone. I will start first of all with my introduction. My name is Sumit Kumar. I am Welcome everyone. I will start with my introduction. My name is Sumit Kumar. I am PMR Research Scholar at IIT ISM Dhanbad. I am taking the course of Geotechnical Engineering 2, in which we are discussing the aspects of geotechnical engineering. Basically, we are applying the basic concepts which we already read in the Geotechnical Engineering 1 to the greater extent so that we could explore the things which we couldn't understood up to this time. So those aspects we are specifically planning to do. So first of all, in the initial class we have studied the shear strength. Afterward, we have now studying the active earth pressure and passive earth pressure. Those things which we are taking in a today class, and this course is taken by Professor D.N. Singh sir, who is from IIT Bombay. And apart from that, some more instruction I want to add from my side, like the content which we discussing over here will be shared with you from the NPTEL team. And if anyone doesn't have access to those content, can text me over here in the text box. I will reply to them as soon as possible. And apart from that, one more points I want to mention clearly that the video which the communication which is going over here will be recorded and I will upload it in the YouTube. So I have seen many of you go over there and see the those classes. So the one instruction for that, please try to attend the live class. If not possible, it's okay. But when you go through those class, you must see that class, and at the end, some questions are there or some conceptual aspects are given to solve by yourself. So solve those problem, and if you feel any problem regarding the same, you can text me in the next class. You can write in the chat box or can communicate with me in the successive class. So it will help you in the better way. So first of all, I will start with the revision session of the last class in first 5 to 10 minutes. In the meanwhile, I hope some more person will join. Otherwise, I will again start with the new content which I have prepared for today. Today, specifically, we are studying the earth pressure at rest condition, active earth pressure, passive earth pressure, and apart from that, we also study in the today class some of the very simple problems which we are going to discuss today. And basically, this is the class over where we will solve the basic problems during this class, but in a coming class, specifically in the next class, we are discussing very good problem. The base which is created by studying, when you study with me during this class, you will understand those concepts. So I will discuss those concepts over here with you, and afterwards, after this class, you will go practice those concepts, practice those sessions, and in a subsequent class, we will start with the advanced problem related to these topic only. So it will help you in a better way. So first of all, I will start with the today content. I think so. My slide visible. Yes, I am also able to see my slides because I already keep the mechanism so I can see my content in a better way. Okay. I think so. Audio and video both is very clear from my side. If anyone have any confusion regarding the slides or anything, you can text me anytime in a chat box. I will try to solve those problems. In a meanwhile, I will first start with the introduction of the lecture which we have gone across during the last session in a very quick, and afterward we will start with the new content which I have prepared for you. So in the last class, what we have studied, we have solved a problem which is based on the tri-Excel test, and it is a very good problem. The two problems we have solved, you must have understood these problems, and if anyone of you doesn't have, you can ask me at the end, or maybe in a chat box. I will communicate in a end of this session. So we have understood the total stress path, effective stress path, and what is mean by the total stress minus static for water pressure, and how we are able to achieve those considerations we have studied during the previous classes. Apart from that, the triaxial test reviews, basically the brief description of the triaxial test, how the triaxial test is performed, we also gone across during the last session, and the mathematical insights will like what are the interrelation between these factors which bisect, which differentiate between the total stress and the effective stress path has been taken into account during that session. The nonlinear behavior of the effective stress path, and how it is connecting with the shear failure by understanding the part that lead to the shear failure. Basically, during that session, we have understood in a very good manner, like when we plot the stress path PQ curve, what is mean by P, like, and what is mean by Q. Q is like sigma 1 minus sigma 3 by 2. Similarly, P is sigma 1 plus sigma 3 by 2. So those understanding we have developed up to extent, and those things will, implementation will be seen in a subsequent section when we study the value of earth pressure at rest, earth pressure in different conditions. So those things we are going across in this and coming classes. Okay. So I will go ahead with this, and during that session, we have understood the stress path, we have understood the value, how the mover circle works, how the stress path differentiate from that sections that has been explained with the help of diagram. The stress path consideration has also represented for you. Apart from that, the PQ curve and the value of P and Q has been discussed, and the total stress path, effective stress path, and the stress path coordinates, how we are able to found each also taken into account, and delta Q by delta P, what do we mean by how the graph represents those sections has been explained. So up to this we have understood in the last class, and at the end we have saw some of the problems related to P Q curve, like P is the sigma 1 plus sigma 3 by 2, and Q is sigma 1 minus sigma 3 by 2. With the help of that, we have solved the problem and identify the value of cohesion and angle of internal friction during that session. Okay, so now what we are going to do? Now we are going to study the value. Now we are going to study the sections which are the prime concern for today, and that section is nothing but in the earth pressure. The earth pressure, in active earth pressure, passive earth pressure at rest condition. So those are the content which we are basically primarily trying to discuss during this session. So, first of all, you see the earth pressure theory. When we go across the earth pressure, we have come in a day-to-day life regarding the active earth pressure theory, earth pressure at rest, earth pressure in active state, earth pressure in passive state. So, what do we mean by earth pressure, and how this earth pressure actually come in the picture? There is always a question in our mind. When we see the earth pressure, we see the log spiral, Coulomb, Rankine, and many more things. If you have little of idea regarding this, you must have understand that these aspects we come across in our day-to-day interaction, day-to-day activity. So how we will deal with that, and how we could understood the fact the active earth pressure, passive earth pressure, and earth pressure at rest condition. So first of all, we start with the earth pressure at rest condition. We discuss every aspect in two different perspectives during this session. So you will get a better understanding of the topic, as well as you will get the two revision. But basically, first of all, I provide the same content in another language with the same notations. Afterward, I will represent the same content in another representation with again same notation. So that will help you to understood the topic, understood the problems which actually framed due to earth pressure condition. Okay. So up to this, everything will be clear. So give me a minute. I will take some water. Okay. So as I am discussing, you must have understood the earth pressure. Earth pressure basically acting in a different perspective in different situations. Basically, when we see when we see a specific retaining wall, over there some earth pressure is there. But if we see any condition like wherever you are living, if you go out from your house, you see the soil. The soil is there, and some construction has been done beside this. Sometimes you see specifically when we draw the foundation, specifically in villages, over there the no design consideration has been taken into account. Specifically, the old construction, you see sometimes there is some cracks has been developed in the foundation, and those cracks has been developed due to the earth pressure, basically the pressure of soil which is exerted on that. So we are concerned about those things only during this discussion, and those parameters we will take care of, and try to solve those parameters in order to achieve our consideration. So first of all, I will start with earth pressure, and that is the first of all, before going to earth pressure, we will discuss the Rankine earth pressure theory. Basically, Rankine only suggested the same factor for the cohesionless soil. Then there is a modification has been provided for cohesive soil as well. So we will discuss for cohesionless and cohesive soil both, and afterwards we solve some problem. After, as we go proceed in this direction, we also see the effect of surcharge. The surcharge also affect the earth pressure, because if there is surcharge is there, then maybe the earth pressure implementation get affected. It may be vary in a different situation in different considerations. So we will go across point by point. So first of all, the Rankine earth pressure theory. So when we talk about the Rankine earth pressure theory, at rest, active and passive earth pressure, there are three considerations. So to analyze the pressure relation between the retaining wall and soil mass, the most commonly used theory is the Rankine earth pressure theory. So the three conditions we are discussing over here is the earth pressure due to rest. Basically, when we talk about the wall is at rest. There is a no soil pressure acting over there. Neither the soil is moving toward the wall, nor the soil wall is neither the wall is moving toward the soil, nor wall is moving away from the soil. So this condition has been said to be earth pressure at rest condition. While when we talk about the active earth pressure and the passive earth pressure, so active earth pressure is that condition in which wall move toward the soil, and the passive earth pressure, and so sorry, in active earth pressure is that condition in which the wall move away from the soil, and the passive earth pressure is that condition in which the wall move toward the soil. So those consideration we are going hand in hand, and those things which we are discussing over here. Now there is a question always there in geotechnical engineering. Wherever we go, we see there is some of the assumptions are there, and on the basis of those assumptions, we are able to frame our consideration. Like whenever from initial classes only, when we talk about our cases, we say the soil is isotropic and homogeneous. So those are the assumptions. So in a Rankine theory also, some of the main assumption is like it assume the wall to be smooth and soil to be cohesionless. As I already said, Rankine theory is for cohesionless, but when we use for cohesive soil, there is a modification that is applied by the other researchers. So this theory extend to the cohesive soil as well with some modification. So we will go up to that as well in this session only. So first of all, we will consider the cases with the help of retaining wall, and with the help of retaining wall, we will suggest some of the cases when the earth pressure is in the active state, when we say active earth pressure, and some other cases when the passive earth pressure is acting. So those things we are going to discuss, and those things come hand in hand, and we are going to understand those facts only during this session. So first of all, every time it is not possible to place the soil unit, it has greater shear strength. Specifically, we have already understood these things in our first two sessions only. So we construct a wall to keep it in place and will fill the soil back to it. Whenever we say either it is possible that we are going to place the soil and up to height of 1 meter or 1.5 meter or 2 meter, it is not possible. Basically, during the construction of any road or maybe railway or any other constructions, if we have to create some bridges or we have to construct some aspects which are at the higher location, so you must have to fill the soil. But it is not like that we keep the amount of, suppose this is a section on which we are placing the soil. So if we fill the soil again upward above this we fill the soil, is it possible that it will retain over there only? So we must have to provide some of the support, and those support has been provided with the help of wall only. So that wall keep the soil in place, and after constructing the wall, we fill the soil back to it, and this is called backfill, and the wall is called retaining wall. And the two assumptions which we have assumed is like the wall is smooth and soil is cohesionless. So this wall which we are talking about is smooth, and when we move forward, so if wall hadn't being there, the soil mass could have come out, which implies the soil mass is applying some pressure on the wall. That is called the earth pressure. Exactly, this is the basic thing which you need to understand. Like if the if it is not going to take place, if there is no wall is there, then the soil couldn't retain over there, so it act as a retaining wall. And if act as a retaining wall, if in a case there is a no wall, the soil got collapsed at that point only. Hence, it must apply some pressure on that wall, and that pressure which has been applied by that soil mass, which is which is specifically the backfill, is creating some pressure on the wall, and that pressure is only known as earth pressure. Now we will move forward and take the consideration of earth pressure at rest, earth pressure in active state and passive state, and we will go in that direction. So only. So we should design the retaining wall against the earth pressure. Now look, this is the picture has been represented over there. The retaining wall has been shown, and the backfill has been also represented. Now imagine a situation. If this wall has not been created, is it possible in any way to hold the entire soil mass without is it possible to hold the entire soil mass without affecting the without getting collapsing that soils which has been present over there? In my opinion, it is not possible, because if we fill the soil, it will go, it will collapse at that point of time in a rightward direction. I will show with some laser. And give me a minute. What I want to point to make. Suppose if this wall is not there, I think so. My laser has been visible. Okay, it is visible. I can see. So if this wall is not there, then this soil mass over here must get collapsed in this direction. So it is not possible to sustain the soil at this point without this wall. So if this wall is not there, this soil get collapsed, then there must be a situation in which this soil mass which is present over there must have applied some of the pressure on this wall, and this wall has that much strength to sustain that much of pressure and doesn't get collapsed and had to sustain the soil mass behind it. So this is actually the backfill, while this is the retaining wall, because it retains the soil beside it, and the soil which has been retained beside it is the backfill soil mass. I think so. Up to this point, there must be no confusion in anyone of anyone mind. Okay. Now, we talk about the design of retaining wall. Basically, design of retaining wall is not our consideration. But the types of load which has been acting on that is the matter of concern for some aspect of time, like the pressure has been acting in the active direction or the passive direction. Those aspects will be there, but we will deal with that in meanwhile. First of all, we will go ahead with our consideration which we are looking at. So while designing the retaining wall, some of the points must need to be kept in mind. So, what are those points? Water does not have the shear strength, hence the stresses in the vertical and horizontal direction are same. Specifically, we already know the water doesn't have strength in a soil mechanism. If there is a water, it is a problem. We have to deal with water. If there is no water, then designing anything will not be difficult at any extent, any point of time. Okay, so whereas the soil has some shear strength and the horizontal stress is a function of vertical stress, so it is said to be the design has been very complex task in itself because the horizontal stress is the function of vertical stress and the all type of stresses we need to be taken in our consideration. Now, we already talked about the wall movement. We have talked about the at rest, active, and passive. So, what are those conditions which we are dealing with and which we are concerned about? The conditions are three in which the different condition has been act at any point of time. So, according to the wall position, this earth pressure changes has been defined, and the general conditions are the wall movement and the wall does not move. The wall at rest is the first condition, while the second condition is wall move away, and the third condition is the wall move toward the back. So in the first condition, it is at rest condition, so there is a no factor affecting at that point of time. But in the second case, when the wall move away from the backfill, the active earth pressure condition generated, and afterward the wall move toward the backfill, the passive earth pressure condition get generated. And why this is happening will need to be understood. Now, understand only one things like if the earth there is earth in the earth pressure at rest, there is a no condition like that in which the earth pressure in which the earth pressure acting in any of the direction against the wall. But in the active earth pressure condition, wall move away. If the wall move away from the backfill, the active earth pressure gets generated. Similarly, if the wall move toward the backfill, the passive earth pressure is condition is generated. So those aspects are there and lead the conditions in which we could say this is the active state and this is the passive state. Now, the wall at rest is the first condition, so the wall and the base of the wall are rigid. And this has been already known to us because it is flexible doesn't matter to us because it has to sustain the high earth pressure, so the smoothness or roughness doesn't matter at all. And as the wall does not move in any direction, the lateral strain, the ratio of change in area to the original area is zero. Uh, Hence the total stress is zero in a way. Hence, this condition is said to be earth pressure at rest condition. Okay. Now we talk about the active earth phase. So when we talk about the active earth phase, the some of the condition get it right. The first condition is wall moves away from the back. In active earth pressure, the movement of wall takes place away from the backfill. Basically, backfill. That's why which has been which has been in that active state. So the wall get moved away from the backfill. Similarly, in the wall move in one direction that is far from the backfill, and the wall and its base are not rigid under this conditions. So these are the conditions in the active state of stress. Now you can see this picture over here. The active pressure condition has been represented. Now look at this picture and take a look and try to understand what is happening over here. Okay. In the meanwhile, give me a minute before I will explain this. See this picture and try to understand. Take a basic aspects about this diagram. What did you understood by this? Okay. So, when you go across with this image, you see the backfill is there, retaining wall is there, but in this case, the retaining wall is tilted away from the backfill. Basically, if in this condition, the wall move away from the backfill, so this condition need to be understood by one and all. This is the condition we are talking about, in which the Earth pressure is in the active, uh, the Earth pressure is in active state. Okay, I think so. Up to this point, the thing is very clear because the wall move away from the backfill. It has been also seen from this picture only. Okay, okay. So I will go ahead. Now you see some of the point about the active earth pressure. So as wall moves away from the soil, because of this, some of the pressure of the soil gets revealed. Hence the shear stress get mobilized, and it is the in OPG, it is in opposition to the wall movement. So this cases has been understood in that manner only, like the shear resistance is in the opposite direction, so the pressure in the horizontal direction get reduced, and as the movement of wall keeps moving away, which will have the condition where the full shear resistance would be mobilized. After a point, there will be any further resistance even if the wall moves away. So this horizontal pressure would be minimum, and it is called the active earth pressure because in this case the wall move away from the wall. So the uh, pressure which has been acting on a wall is in relatively less quantity as compared to what it would be in the natural condition. So this condition, the earth pressure which has been acting at that point of time will be minimum. Okay. Okay. Now we talk about the passive earth pressure. So we have gone across the active earth pressure, basic understanding, passive earth pressure, basic understanding. Afterward, we will discuss these things in another aspects. When we talk about the another aspects, what is that aspects I am talking about? So, when several times it has been seen that the people get confused between the active and passive earth pressure, but these things, and sometimes they say the active earth pressure is the inverted passive earth pressure. The mark in the mark or the things which you relate, like the active earth pressure and the passive earth pressure goes hand in hand, and it is exactly opposite. So this is only happen with the coefficient of earth pressure. If you talk about the coefficient of earth pressure in the active and passive state, we already we didn't take 1 minute to answer that question in that. So they have no liberty of giving the uh, liberty to take the active and passive earth pressure in a converse way in any possible cases. Okay, so when we talk about the passive earth pressure, the wall moves toward the backfill, and due to the mass of creating a wall and its speed at which it moves, the mass of the soil tend to move upward, and this is the cases. This is that case which we didn't looking earlier. Basically, we didn't have concern about. In this case, the section get moved toward the backfill during this, and due to the mass of creating a wall, the speed at which it moves, the mass of the soil backfill tend to move upward. And you can see, as in the previous cases only, if you find the value of the earth pressure due to the backfill, and when the backfill move toward that, the earth pressure has been said to be passive earth pressure. Again, we can see this with the help of diagram. Earlier, we also see the diagram. Over there, you can see that the wall is moved away, but in this case, toward the backfill, one retaining wall is going. So the passive earthquake pressure condition get generated. In this case, the shear stress act is same in the all direction and the horizontal pressure. There will be a situation where the stress can't to be maximum. Then that is the passive um, earth pressure in a real sense. Okay, so up to this, everything is crystal clear. Now, we talk about the Rankine pressure theory. We see the some of the assumption which has been proposed by the Rankine. So the Rankine theory assumes that there is the no wall friction, and the no wall friction means the value of delta is zero, and the ground and the failure surfaces are straight planes, and that the resultant forces act parallel to the backfill slope. In the case of retaining structure, the earth retained may be filled up with earth or the natural soil, and these backfill material may exert a certain lateral pressure on the wall, and if the wall is rigid and does not move with the pressure exerted on the wall, behind the wall will be the state of elastic equilibrium. So these things need to be understood in the uh, real sense, like what is happening when we talk about the earth pressure theory of Rankine. So these backfill material may exert the certain lateral pressure on the wall, and if the wall is rigid and does not move with respect to the pressure exerted on the wall, behind the wall will be state of elastic equilibrium. So these points need to be understood. During the last class also, we have talked about the some of the elastic and inelastic equilibrium, or like the people how use the earth pressure theory in a real way. So these things has been very much clear. Now we will consider some of the cases. Before that, I will take a 5 minute break. Afterward, I will start. I will start at 3:50. Welcome back. So we will again carry on discussion. So we are talking about the earth pressure. So we have come across the three situations in earth pressure at rest condition, active earth pressure, and passive earth pressure. So we go one by one for all the three cases, and we will try to understand the situation of the field. Actually, what is going to happen in field and how we can replicate, how we can understand and replicate the field condition for our understanding, our knowledge, because with the help of that we have to design. Because these days, any constructions taking place, if we talk about infrastructure construction, if we talk about household construction, so what there you see that the level of soil become very important. So we try to sustain the soil up to certain height. So for that, we are creating different situations, different circumstances. With the help of that, we are able to achieve. So those aspects we are looking into that. So first of all, consider a prismatic element in a backfill as a depth jet as shown in the field. This is the condition over where we are discussing. Okay. So this is the condition when we talk about the lateral earth pressure for the rest condition. So you see we have considered a section and we have gone up to depth j, and this is our height h in which we go up to depth j. The element is, has been seen, the vertical stress and horizontal stress are represented. But when we see at depth j, the value of earth pressure is K naught gamma j. Now the question arises, what is the value of K naught in rest condition? What is the value of K naught in the active state of stress, and what is the value of K naught in the passive state of stress? And another more important question, what are the value of the resultant earth pressure at depth h? Basically, the overall whatever the height of wall we beside which we have tried to sustain our loading, it must apply some of the pressure on its wall. The backfill must apply some of the stress, some of the pressure on the backfill. So how we are able to find those, and how those will help in understanding the section, understanding the aspects of the active and passive state of stress. So those things we are taking care of in this section. Okay. So I think this thing is clear. Now, first of all, you understood that when we talk about the earth pressure, we have drawn the pressure diagram of soil up to the section which we are willing to find the earth pressure. So we have drawn the earth pressure diagram. Afterward, we have to multiply that with the coefficient of earth pressure, either be the earth pressure at rest condition coefficient or the active state of stress coefficient or passive state of stress coefficient. So we have calculated that only sigma h cannot gamma z, and similarly we able to find the value of the resultant earth pressure as 1 by 2 K naught gamma h square. And we know this is taking place in the earth pressure diagram formed in the triangular portion. So the section on which this earth pressure acting is at the center of gravity of this triangle, that is the h by 3 from the base and 2h by 3 from the top. Now, you must need to be understood if this condition get reversed, not reversed, but if the cohesion is there, then the resultant earth pressure must be at some other places. So we need to calculate in those cases the position of earth pressure. So the two types of questions framed over here, in which we have to either find the earth pressure at certain section, or in a second question we have to find the resultant earth pressure. If we have to find the resultant earth pressure, we take the area of earth pressure diagram multiplied by k, and that will be the going to the value of earth pressure, and that value will be in kilonewton per meter. Similarly, if we are concerned about finding the earth pressure at certain section, it will be the earth pressure at the depth z only, and that will be in the kilonewton per meter square. Okay, so now see the element E is subjected to the pressure which has been shown over here. The vertical stress is the gamma jet, and the earth pressure coefficient is the horizontal earth pressure by the vertical earth pressure. It is the ratio of horizontal earth pressure to the vertical earth pressure. So vertical earth pressure we already understood. Now the lateral pressure is sigma h, where G is the effective unit weight of the soil. If we consider the backfill is homogeneous, then both the value of sigma V and sigma H increases rapidly with the depth Z. In that case, the ratio of the vertical and lateral stress remain constant with respect to depth, and that is the sigma H by sigma V. And this constant K naught is called the coefficient of earth pressure for rest condition. And this coefficient has been calculated for rest condition in several ways. The most simple way is using the value of mu by 1 minus mu, where mu is the Poisson ratio, second is the 1 minus sin phi. And what are the those terms we will understood in coming slides. So, when we talk about the Rankine earth pressure theory, I already said I will take the two perspective of every theory and refer you the two frame of reference to um, method of understanding the specific topic will help us to make a idea about what we are talking about. Okay. So the Rankine theory was only applicable to the uniform cohesionless soil. This is already said. And how we will modify to the cohesive soil, we will see in that. So, the originally proposed for the cohesionless soil, but later Bell. Basically, the Bell theory that has been said at some point of time in 1915, the Bell has came into picture. He is one of the researcher who has extended the Rankine theory only for the cohesive soil, and with the help of that, in the present day time, we have going to solve the earth pressure problem. So all the soil mass in the plastic equilibrium and remain at active passive earth pressure. This means for every point in soil the shear failure is just about to happen. Okay, this is exactly true point. In reality, only the part of soil mass will be in the plastic equilibrium. Okay, now we will see the assumption which we are taking into the account of the Rankine earth pressure theory, and these assumptions are only the limitation when we talk about the limitation of Rankine earth pressure. In the later classes, we already also read the Coulomb theory, Coulomb wave theory, Kalman theory. So we must need to understand that which theory has what assumptions and whether the assumption has a act as a great limitation in some way or the other. So those aspects need to be seen at every aspects. Okay. So some of the important assumptions of the Rankine pressure theory are that the soil is isotropic and homogeneous. This has been understood it very clearly, which means the value of cohesion, angle of internal friction, and the gamma have the same value everywhere, and they have the same value in the all directions at every point. Because if that doesn't going to take case, we are the solving the specific problem or taking the care of field consideration become very difficult in a real sense. Okay, so the strength of the vertical plane is same as that of the horizontal plane. We have note this theory is also applicable for the multi-layered soil. When we talk about the multi-layered soil, no, in the different layer, the value of cohesion gamma is not going to be same, but it get vary. And on the variation of value of phi in gamma and C, we are able to calculate the value of stress at that section by applying the Ramkine's theory or the Bayes theory, whichever are applicable for the cohesion lesson, cohesive soil respectively. Now over here I already see the C is the value of cohesion, phi is the angle of internal friction, and gamma is the angle of internal friction of the soil. Okay. Now, again, we see some more points about this Rankine theory. The while is infinitely long means the problem may be analyzed in the two dimension. Basically, we have considered the while to be very long. It has been getting extended in a that direction up to very larger. Now, the geotechnical engineers consider this as a plane strain condition because we already know if the third dimension has been going to be indefinitely long, so that is the plane strain condition. Now, the ground surface is also considered plane, although it does not necessarily need to be level, because we have said the ground surface is plane, but is it level or not, that has been not taken in our consideration. The no wall friction is there, basically the wall is smooth. We have considered the wall to be smooth, so the no wall friction will be there, because it has been seen in the very second or third slides when we have talking about the Rankine theory. Okay, so the wall is sufficiently to develop the active and passive condition. This need to be understood. If the wall doesn't have strength, in that cases the wall get collapsed. So it has that much strength, so it will achieve that stress, and the active and passive state of stress get developed over there. Now, the most critical shear surface in a plane, in reality, it is slightly concave up, but this is a reasonable assumption, especially for active cases, and it simplifies the analysis. The resultant of the normal and the shear force that act on the back of the wall is inclined at angle parallel to the ground surface. Now we again see the Rankine earth pressure wall at rest condition in some detail. Over there, specifically in the earlier, we have seen we have drawn interface in that we have gone to up to depth Z, and on that section we are going to calculate the value of earth pressure at rest condition. Now we are developing our concept. We are going to find the value of K naught. How the earth pressure at rest condition will be calculated in the real sense. We are going to discuss those consideration over here. Okay. So I think so these points are more or less clear. Okay. So this theory of elasticity is used over here. Here there is a zero displacement, so the zero strain, and the soil is homogeneous, isotropic, and semi-finite. The elastic modulus and the Poisson ratio is constant for the total stress mass, and the coefficient of earth pressure at rest condition, or the rest earth pressure constant, is denoted by K naught and defined by the ratio of lateral earth pressure to the vertical earth pressure. This has been already discussed in a different consideration in previous to previous slides, where at any depth z the vertical pressure, the sigma p is gamma z, and that has been multiplied by the value of K naught, that is the constant parameter for the specific void when we go at a certain depth. So where the gamma is the unit weight of the soil. Okay. Now you see the I already said the value of position Poisson ratio, the coefficient earth pressure coefficient at rest has been defined in the term of Poisson ratio, and that relation is K naught equal to mu by 1 minus mu, and by this we are able to find our solution of the problem which has been given. But this is not only the aspect. Suppose the Poisson ratio is not be if you are not able to find, but that will not be going to be the case. But if this has been case, the solution has been given in a real sense. Now, when we go for calculation, the earth pressure at rest condition, the coefficient K naught is applicable for determining the active pressure in the clay for the saturated system. Because of the cohesive property of the clay, there will be no lateral pressure exerted at rest condition up to the same height at the time of excavation is made. However, with the time the creep and the swelling of the clay will occur and a lateral pressure will develop. The coefficient takes the characteristics of the clay into the account and will always give a positive lateral earth pressure, and the lateral earth pressure acting on the wall of height as may be expressed as uh, K naught gamma h, and the total earth pressure of the soil at rest condition has been given as 0.5 K naught gamma h square. So we have seen this with the help of symmetric diagram as well. Over here we again had been gone across those aspects to develop our understanding in a better manner. So I think so up to this the things are more or less clear. Now we will see the different value which K0 could achieve when we are talking about the rest condition. Okay, so the value of K0 depends upon the reliability, relative density of the sun, and in the process by taking the deposit was formed. So in this process does not involve the artificial tamping or the value who ranges from 0.4 for loose to the sand to the zero point 0.6 for the dense sand, and tamping of layer may increase up to 0.8, and from the elastic theory k not equal to mu by 1 minus mu, where mu is the Poisson ratio, and according to Jack in 1944 a good approximation k not as given by k not equal to 1 minus sine phi. So those points need to be understood, and those consideration need to be understood by us in a better manner in order to deal with the problem related to this section. Okay. Okay. And now over here you can see for the saturated clay, for the unsaturated clay, for the sandy soil, for the silty soil, for the dense sand, for the porous and for the fine grained soil, and for the rock, the value of Poisson ratio has been stated, and with the help of Poisson ratio, we are able to find the coefficient of earth pressure at rest. That is the value of K naught, which has been in the different value depending upon the value of the Poisson ratio for the different type of soil mass. So these relations is just for your understanding. There is no need to remember these things. Yes, but sometimes it will help you in some way or the other in order to find the solution of some problem. There is a some problem may be framed. If we talk about some of the popular value of the Poisson ratio for the some of the different specific consideration of soil, we are able to answer the aspects regarding the sin. Okay. So now we can move ahead. There will be a problem when we are going to solve the problem. There will be a problem over there. Over there, the type of soil has been given and the poison ratio that doesn't have been given, and you have to find the value of unstable electricity condition. Over there, we use this case only. Okay. Now, this is not only the case, like we have always have a normal concentrated soil. There may be different type of soil, maybe over concentrated. So how we able to find the value of K for K naught for different type of soil? So there is a researcher named Jackie in 1944 have give the good approximation for K naught as 1 minus sine phi, where phi is the angle of internal friction. And this thing is widely used because you have rarely see the value of Poisson ratio used while calculating, because this consideration help to reduce our working process in solving the problem. We don't need to calculate the Poisson ratio, the angle of internal friction is already stated in some way or the other. So the with the help of that we are able to state our solution. So the for normally considered clay K naught has been also written as 0.19 plus 0.233 log IP, where IP is the plasticity index. So if some point of time if the plasticity index is stated and you have to find the value of K naught for the normally considered soil, you are able to find this with the help of this interrelation. Another interrelation is the over for the over concentrated clay, the value of K naught has been given as K naught in the normal concentrated state multiplied by over concentration ratio. So you can see how we are able to predict the value of coefficient of earth pressure at rest condition in a different situation and different circumstances. Okay. So we will go ahead. So the lateral earth pressure at any depth z will be sigma h equal to k naught multiplied by sigma b, and sigma b is nothing but k naught gamma z. So our value is k naught gamma z, and that will be the value of earth pressure which has been acting in the horizontal direction. If we are taking this value up to the greater extent, we are concerned about the finding the total earth pressure. So in that cases, we are going to calculate the area of this pressure diagram multiplied by the coefficient of earth pressure at which condition, and be able to state the solution of the problem. So similar case has been arise, but there will be a problem get developed when the soil is cohesive. So we will see that. Okay. So over here the same thing has been written like the resultant pressure at rest act at a height h by 3 from the bottom of the pressure denoted by P naught, and P naught is the area of triangular pressure diagram. So P naught equal to 1 by 2 gamma h into K naught gamma h, like the 0.5 K naught gamma h square. Okay, so we will go ahead. Now the active earth pressure condition we will looking at. We already know the active and passive earth pressure condition are the two conditions. In the first condition, active earth pressure, the wall move away from the backfill. In the second condition, the retaining wall move toward the backfill. And in both the cases, we have understood the basic concepts. Now we are going to develop the value of the coefficient of earth pressure in the active state and the coefficient of earth pressure in the passive state respectively. To understood the value and aspects, we also comes to know that why the value of K naught and the coefficient of earth pressure in the active states is always less than the passive states. What are the factors which has been working during our study of the earth pressure? So we are going it in that direction only. Ah, okay. So we will start with this active earth pressure condition. Okay, we have to go a little faster in order to complete the entire content for the today's session. No problem, I will look into that. That all problem will be solved in a given duration of time. Okay, so because I have kept almost 15 problems, approximately 15 to 20 small problems at the end of the session. So you will get a better practice of the things which we are discussing over here. Okay. So the active pressure condition we are talking about. So in this condition, the wall move away from the backfill. This has been understood. But at this point of time, we are concerned about the getting the value of the coefficient of earth pressure. How we are able to calculate this for the cohesive soil and respectively for cohesion less soil. We have understood with the help of entire theory for the cohesion less soil, but how we are able to communicate for the cohesive soil. So in this condition, the wall move away from the backfill and the plastic equilibrium in the soil refers to the condition where every point in the soil mass on the verge of failure. So the general formula for the lateral stress sigma h in acting condition is sigma h equal to k into gamma z minus 2c dot k. In this case, we already know we up to that when the soil are the cohesionless. In that case, sigma h equal to k not into gamma z or k into gamma z. But when the soil is cohesive, the base theory is applicable and our interrelation get changed from K gamma Z to K gamma Z minus 2C root K. So these interrelation will need to be remember because when we see in a cohesive soil the maximum unsupported depth for the excavation. Afterwards, we have to provide the some of the supports in order to excavate. So those things in a cohesive soil specifically talking about. Over there, the value of K, that is the coefficient of earth pressure in the active state, is 1 minus sine phi by 1 plus sine phi, and that is the 10 square 45 minus phi by 2. And that has been also written as cot square 45 plus phi by 2, which has not been written over here. So our interrelation gets changed from gamma z into tan square 45 minus 5 by 2 minus 2c root k, so the tan 45 minus 5 by 2. So in that case over here the value of c is the cohesion of soil and the k is the active earth pressure coefficient, whereas phi is the angle of internal friction. So up to this the things are very much clear. Now, when we plot the diagram for the cohesive soil, for the pressure diagram specifically, we are talking about the earth pressure diagram. So the minus 2c root k has been clearly represented because at depth z equal to 0, basically our interrelation, what is our interrelation? I will write this so you will understood in a better manner. I will take the pencil and I will write. Okay. So see, our interrelation is sigma h is equal to k gamma z minus 2c root 2. I think so up to this the things are very much clear. Okay. Now at z equal to 0, or it has been written at z equal to 0, the expression of the lateral earth pressure become sigma h equal to minus 2 c root k. Okay. So you see at z equal to 0, at z equal to 0. I think so up to this, the things are very much clear. Now, similarly, when we want to find the distance of after that, the value of at this point, the state of stress is zero. The total state of stress not, but the state of stress at this point has been zero, zero. Okay. So there is a question has been framed that at which depth the active earth pressure acting is zero. So this is the point over here zero. And if we go up to this point like this, and if it will be 4c by gamma root k, if it will be 4c by gamma root k. Okay. So if this is the case, if this is the case, so this is the maximum unsupported depth. Alright, maximum unsupported depth. Basically, when we talk about the maximum unsupported depth, we are talking about the section. When we talk about the maximum unsupported depth, we actually talking about, okay. When we talk about the maximum supported depth, we are talking about the section over there. The total stress. Total stress is also zero. Total stress is zero. Total stress is also zero. Because the this is negative and this is positive, so the total stress at this point will be zero. Apart from that, the development of tension crack and development of tension crack and some more points will also be there. So those things we will discuss in a later time. But up to this point of time, these things must to be clear in a very clear way. Okay, things will be very much clear at this point. Okay, so the value of sigma h has been minus 2c into 10 25 minus 5 by 2, which has been represented over here. Now, for the cohesive soil, we have seen. Now we are talking about the cohesionless soil. For cohesionless soil, we already know the sigma h is the k into gamma z. So the value of k has been known to you like 1 minus sin phi by 1 plus sin phi. So that has been 10 square 45 minus 5 by 2. So the sigma h value is sigma h equal to gamma z into 10 square 45 minus 5 by 2 value. So this understanding is very clear. So in this case, the negative side of pressure distribution doesn't create it. The value has been drawn as the earth pressure only, and then that value z equal to 0, sigma h will be 0 because k gamma z minus 2 c naught k, and at z equal to 0, the sigma h becomes 0 because the 2c root k doesn't add because the c value is 0. So the pressure distribution start from the origin and it will draw in a similar manner. Okay, now we talk about the failure plane. If we talk about the failure plane, so the failure plane in the soil makes 45 plus 5 by 2 degree angle with the direction of the major principal plane, and that is the major principal plane is the horizontal plane when we talk about the active state, and this is called the potential slip plane. So this thing needs to be understood. Now we again take the same consideration like we have already said we study everything two times, so our mind grasps those concepts in a better way in order to sustain the things for the longer time. The same thing has been mentioned over there, the active state of stress. Basically, this diagram doesn't have earlier, so over here you can see the inner input planes and how the pressure has been acting in the active state when the wall is moving away from the backfill. This over here you can see over here you can see the wall is moving away. uh, Wall is moving away from the backfill. So how the stress get developed, these things have been represented over here again and again for you. And the things which has been written will be again I will read you and some I will add some another points for the audience who are present over here. So the lateral earth pressure acting against a smooth wall AB is due to the mass of the soil ABC above the rupture plane as seen in the last picture in the last slide. So the lateral pressure acting against the horizontal with the horizontal and the lateral pressure distribution on the wall AB of which make an angle 45 degree, that is the 5 by 2 height h increasing in the same proportion to the depth, and the pressure act on the normal to the wall AB. So the lateral active earth pressure at A will be Pa equal to K gamma h, which act at distance h by 3 from the base, which we have discussed at the several point of time. For that, there is a if we are concerned about getting the value of total stress, we write the value equation for Pz as K into gamma z, and we will integrate from depth 0 to h, and on that basis we are able to find the total stress which is acting at that point of time, that will be the 1 by 2 K gamma h square. And over there the K is the value of tan square 45 minus 5 by 2 I think so. And otherwise the better thing is you will write K is 1 minus sin 5 by 1 plus sin 5. Okay. Now the passive earth pressure condition. Now we are dealing with the passive earth pressure condition. So in the passive earth pressure condition, the wall is moving toward the soil, so the stress in the horizontal direction become the major plane, not the direction perpendicular to that. So we are concerned about the direction, horizontal direction over there, because the stress in the horizontal direction will be more as compared to the vertical direction. So this is the most basic thing which has need to be understood by one and all. Okay, so we will go with this consideration. Okay, I think so. Things will be very much clear up to this. There will be no confusion up to that. I don't think so. There will be any confusion. So we will go ahead similarly, and we will take the things and understood the different aspects. Okay, so give me a 1 minute. Okay. Okay, so we are talking about the passive earth pressure condition. So in this condition, the retaining wall moves toward the soil mass. We have talked about this state again and again, again and again, and we are now concerned about getting the expression in order to find those aspects for us. So the expression is quite similar to the active state of stress, but there is some interchanging of the signs. Over there, we already know that the soil wall move away from the backfill, so the pressure in the horizontal direction get reduced. So the negative sign is there between the value of K gamma J and 2C root K. But at this point of time, the wall is moving toward the soil, so the stress acting in that direction will be more as compared to the vertical direction. So in that case, the sigma h becomes the kp gamma z plus 2c root k, and that thing has been presented over here only. Okay. At this point of time, kp is the value of 1 plus sin phi by 1 minus sin, and it has been also written as the tan square 45 plus 5 by 2. There is no problem with that. And so related the value of sigma h has been written as gamma j tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2, because the kp value is tan square 45 plus 5 by 2. So the root kp is the tan 45 plus 5 by 2. Okay. Now, now you will see the pressure distribution diagram has been represented over here. Now the question might be arising in your mind. This is the pressure distribution diagram, not the earth pressure diagram. So, at as we know, the value has been already known to you as Ka gamma z plus 2c root k, Ka gamma z plus 2c root k. Okay, Kp. Sorry, passive. We are talking about passive. So this is not k. This is k. Okay. So at z equal to 0. At z equal to 0, the pressure will be 2c root kp, 2c root kp. At z equal to 0, the pressure will be 2c root kp. This term become 0. Okay. So this section is nothing but 2c root kp. 2c root kp. So in that way, the stress distribution diagram has been created. Okay. Up to this point, there will be no confusion, I think so. Okay. So the for cohesion less y c equal to 0, so the expression of the lateral pressure is sigma h equal to kp into gamma z, where k equal to 1 plus sin phi by 1 minus sin phi. No, this thing is, I think so, converts k equal to 1 minus sin phi by 1 plus sin phi, and cot square 45 minus phi by 2. So sigma h equal to this. Okay, for there is a correction has been needed. This is kp. Okay, rest of things is okay. 1 plus sin phi 1 minus sin phi times 41 plus phi. Okay, so the payload plane similarly as we have seen in the active state of stress, for the passive state of stress, for the inclined passive state of stress, it make an angle 45 minus 5 by 2 as shown over here with the horizontal. So the it make 45 minus 5 by 2 degree angle with the direction of the minor principal plane. So in this case, the minor principal plane will be going to be the plane which has been represented, that is the horizontal direction. Okay. Now again we can see in that case, in this case, wall is moving uh, toward the backfield, wall is moving toward the backfield. So this case has been taken in that way only. Okay. I think so. This thing will be clear. And again, in this case, how the stress is acting, at what distance it has been acting, will be presented in a crystal clear manner. Okay. Now, again, we will take some point of the inclined passive earth pressure condition. So, the inclined passive earth pressure in the cohesionless Y, if the wall AB is pushed into the mass to such an extent as to impart the uniform compression throughout the soil mass, the soil wedge ABC in the figure will be the inclined passive state of plastic equilibrium, and the inner rupture plane AC makes an angle 45 plus 5 by 2 with a vertical AB, and the pressure distribution of the wall is linear as shown in the previous diagram only, and the lateral passive earth pressure at A as P equal K gamma H, Kp gamma H, which act at height h by 3 above the base of the wall, because it takes place in a similar way. For up to runtime, there will be no problem in the calculating the stress. So the total press area, again, as we have calculated the total stress by difference integrating the whole section from 0 to h. In a similar way, over here as well, we are going to integrate from 0 to h, and we will finally consider our solution in a true sense. Okay, so over here as well, the value of kp has been represented, and hence our answer has been found. So up to this we have solved the Rankine theory. Afterward also the some more points in the Rankine theory has been left, that is the surcharge and how the surcharge helps. There will be some question in which there will be asked the how much surcharge we have to keep on the soil in order to reduce the chances of the development of the negative state of stress which has been developing in the cohesive soil. So those points will be coming in the next lecture. In this lecture, we will see the Rankine theory up to this extent only because of the time constant, and we will move to that section as well in a coming sessions. Okay, so up to this point there will be no confusion. So we will move ahead, and we will see now the column based theory. Okay, so the column based theory. When we talk about the column based theory, at the first slide only you have seen the several diagrams representing these things. So now we come to that section now. So the Coulomb based theory. What do we mean by the Coulomb based theory? We are concerned about that. Yes, absolutely. So the Coulomb theory provides a method of analysis that gives a resultant horizontal force on the retaining system for any slope of wall friction, and the slope of the backfill provided. This theory specifically is based on the assumption that the soil is shear resistance developed along the wall and the failure plane, and the coefficient is for the resultant pressure acting at angle. Since the wall friction required a curved surface of sliding to specify equilibrium, the Coulomb formula will give only approximate result as it assumes planar failure surfaces. The accuracy for the Coulomb will diminish if the sorry, increased depth for the passive pressure. The Coulomb formula can also give an inaccurate result when there will be a large back slope or the wall friction angle. So these conditions should be investigated and the increased factor of safety considered. In the Coulomb-based theory, Coulomb in 1776 developed the method for determining the Earth's pressure, in which consider the equilibrium of the sliding wedge in the form of the movement of the retaining wall takes place, and the sliding wedge is torn off from rest of the backfill due to the movement of the wall in the active earth pressure case. The sliding wedge moves downwards and outward on the slip surface relative to the intact backfill, and the case of the passive earth pressure. The sliding wedge moves upward and inward. The pressure on the wall is in fact a force of reaction which it has exerted to keep the sliding wedge in equilibrium. The lateral pressure on the wall is equal and opposite to the. Okay, sorry for disturbance. Okay, so the sliding wedge is a turn off from the rest of the backfill due to the movement of the wall in movement of the wall. In the active earth pressure case, the sliding wedge moves downward and upward on a slip surface relative to the intact backfill, and in the case of passive earth pressure, the sliding wedge moves upward and inwards. The pressure on the wall is in fact a force of reaction which it has exerted to keep the sliding wedge in equilibrium. because equilibrium is necessary. If we are not able to keep the things in equilibrium in a true sense, it will sorry, create problem for us. The lateral pressure on the wall is equal and opposite to the reactive forces exerted by the wall in order to keep the sliding wedge in equilibrium. The analysis which we do for this case is a type of limiting equilibrium method in a true sense. Okay, so the sum of the assumptions which are has been made during this Coulomb wave theory is like the vacuum. These assumptions are very much important. Sometimes this assumption has been asked. So the vacuum is dry, cohesionless, homogeneous, isotropic, ideally plastic material, elastically undeformable but breakable. The slip surface is a plane surface that passes through the hills of the wall. The wall surface is rough. The resultant earth pressure on the wall is inclined at an angle normal to the wall, where is the angle of the friction between the wall and the back. So these things are very much considered because these assumptions become very important in a true sense, because sometimes you see in a many examinations the questions comes from the assumption only. If you doesn't have the control on the assumption, in several competitive exams as well, the question has been developed with the help of assumption, and you have no idea, no clue how to solve. But if you have created the you have developed the understanding about the assumptions, are easily able to solve it. So the sliding wedge itself acts as a rigid body, and the value of earth pressure is obtained by considering the limiting equilibrium of the sliding wedge as a whole. The position and the direction of the resultant earth pressure are known, and the resultant pressure acts on the back of the wall at one-third height of the wall from the base and is inclined at an angle normal to the back. The angle is called the angle of wall friction, and the back of the wall is rough, and the relative movement of the wall and the soil on the back take place, which develop the frictional force that influence and direction of the resultant pressure. So these things are there. These things are as a assumption. In the Coulomb theory only, the plane failure is assumed, and the lateral force required to maintain the equilibrium of the wedge is found using the principle of statics. The procedure is repeated for the several trial surfaces, because in the Coulomb wedge theory we have taken the wedge, the trial surfaces which gives the large forces for the active cases and the smallest forces for the passive cases is the actual failure surfaces. This method readily accommodates the friction between the wall and the backfill, irregular backfill, sloping wall, and the surcharge loading, etc. Although initially the theory was for the dry, cohesionless soil, and it has been now been extended to the wet soil and the cohesive soil as well. As we have seen, the Rankine theory takes place in a similar manner. Over there, the Base has modified the theory in order to obtain the cohesive soil and the result for the cohesive soil. Okay, so the Coulomb theory is more general than the Rankine theory. Exactly. Now, the Coulomb active pressure in the cohesionless soil, the below the figure which has been given ahead, show the retaining wall with the inclined back face sloping dry granular backfill. In active cases, the sliding wedge ABD move downward and the reaction R act upward. So, and upward, and the inclined angle F dash at the normal. The sliding wedge ABD in equilibrium under the three forces. The forces which are there are the weight of the wedge. Okay, weight of the wedge, the reaction R on the slip surface BD, and the reaction PX from the wall friction of the earth surface. Okay, so for the condition of yield of the wall away from the backfill, the most dangerous or the critical slip surface is that for which the wall reaction is maximum, and that is the wall must resist the maximum lateral pressure before it moves away from the backfill, and the lateral earth pressure under this condition is the active pressure. The critical slip surface, the critical slip surface for the case of the passive earth pressure is that for which the wall has the exert a minimum force to tear off the soil wedge by moving toward the backfill. Okay. Now, the main deficiency of the theory, basically we have taken the assumption, so the limitation is from there only. So the theory is the assumption that the slip surface is planar. Therefore, the force acting on the sliding wave does not generally meet when in the static equilibrium condition. The actual slip surface is curved, especially for the lower part, and the assumption of the plane slip surface do not affect the materially the resultant of the active case but give the very high value in the passive cases as compared with the assumption of the curved slip surface, so that the overestimation underestimation facts come in picture. Okay, so the principle of sliding wedge has been extended for calculating the earth pressure of the cohesive soil. Now, for the figure which has been given ahead, so the force triangle means the W, PA, everything has been represented. So as a magnitude of one force W, the weight only has a direction and all the three forces has been known direction. The force triangle can be completed and the magnitude of PA is determined from the force triangle. The pressure acting on the wall is equal and opposite to PA. The procedure is repeated after assuming the another failure surface, and the surface that gives the maximum value of PA is the critical failure planes. The corresponding forces is the active forces, so we will go with that one. Now, the Coulomb method does not give the point of application of the Earth specifically. Basically, it doesn't talk about the. Basically, when we talk about the runtime theory, we say that it acts at h by 3 from the base, or the different cases we are taking different consideration. But when we go in the Coulomb theory, he doesn't say that this force act at this point. The point of application will be this found. So we found approximately at the point of intersection E of the wedge, approximately of the back of the retaining wall with the line C drawn from the centroid C of the failure wedge and the parallel to the surface. As the procedure is cumbersome for the convenience, the pressure distribution is sometimes assumed to be hydrostatic on the back of the wall, and the resultant pressure PA assumed to act on the one third of the wall from the base. So in this way, the Coulomb theory works on. Okay. Now the following are some of the points should be carefully noted while using the Coulomb theory, because Coulomb before using any theory you need to understand its pros and cons. So some of the points we need to be take care of before going to using this theory. So what are those points? We need to rectify the problems which has been created because of those aspects. So we need to go across those considerations. Okay. Now the points are the for the most of the practical cases the backfill moves downward related to the wall in the active cases, and therefore the active forces PA and inclined delta at an angle below the normal. However, if the wall is supported on soft compressible soil, it may settle too much uh, to such extent that the movement of the wall will be downward relative to the backfill and the relative movement of the wedge will be upward. In such cases, the PA would be inclined at an angle delta above the normal of the wall, and the delta is the friction angle between the soil and the wall, and it may be determined the means of direct test. Okay, so from initially we are talking about the W. The W has been shown, the R has been shown, the PA has been shown. We are talking about this only. After that slide, you can go with this, and what we have discussed you will easily understood. So this is the expression of the active pressure for the cohesionless soil which has been shown over here. Okay. Now we have taken this as a base and we and try to frame the interrelation in which we are able to find the weight of the soil. Because if you are talking about the weight, if we take the area and the unit length depth beside and multiply the value of gamma, we are able to find the weight of the soil base. Okay. So now when we use the sine law from the previous diagram, the active force component of the weight vector has been shown from the figure above. The PA as sine alpha minus phi dash as W by this, and from solving we take the different angle inclination. We are able to calculate the value of AB. Now we are able to calculate the value of W. Similarly, we are able to find the value of PA and delta and beta. So the K value has been calculated. So these things, the extra things, this need not to be remembered. Just go across the because there is a limitation of time. So maybe I will discuss this again in the next class. You doesn't need to remember these concepts are extra doesn't required for you at this point of time. And this is only for the understanding purpose. Now I will go with the problem because I have taken many problems over here, so I don't want to miss those problems before going. Okay, some of the graphical methods are there for the lateral earth pressure. That is the Kalman solution, trial wedge method, logarithmic spiral, and the Kalman solution. We will go about that in a little, very little extent coming classes. And before that, moving ahead, we will go with some of the questions. So the questions become very important in this discussion. We will discuss very small problems. Afterward, we will take some good problems in from the next class. In the next class only, not from the next class. So you will able to understood the problem solving strategy, how to solve the problems which has been developed on these topics. Okay. So the first question is like the Rankine theory for the lateral earth pressure can be applicable only to. So from the initial only we have understood the Rankine theory there, then the Rankine theory is modified by the Bose. So the answer for this problem needed to be very clear in your mind. It's like this theory has been applicable for the cohesionless soil only because for the cohesive soil this has been modified by the Bells. So when it has been talked like whether the Rankine theory is applicable for the lateral earth pressure calculation in the cohesive soil, you see no. So, in addition, you add your explanation. You say this has been proposed by the Bells, which has been extended the Rankine theory in order to apply in the cohesive soil. So, you can state the solution. So, these things need to be understood and very crystal clear in your mind. Okay. So that solution has been repainted. So as originally proposed, and kind theory of the lateral pressure is applied for the uniform cohesion less soil only. Later it was extended to include the cohesive soil as well. Okay. So these things will be very much clear, and these are the most basic aspects which need to be clear in everyone's mind. Now, the next problem is unkind theory of the lateral earth pressure was exerted to the other soil by. Okay, so I already answered this problem in the previous problem only. That who extended the unkind theory, so it has been applicable for the other soils because initially it has been proposed for the cohesion plus soil only. So the for the use in the cohesive soil, someone has extended. So our options are Russell and Bell, Mohart, none of them mentioned or all of the above mentioned. If the answer is all of the above mentioned, then the Russell, Bell and Mohart will be answer. But we already know it as a Bell's theory. So our answer will be going to be option number A. And when we read the explanation for this, the theory of the lateral earth pressure was extended to the cohesive stratified and the partially immersed and submerged soil was by Russell in 1910 and by Bell in 1915. But he mostly concerned about the Bell's theory because we already used that theory only, that modification only in solving the problems in understanding in implementing the real field situation in the actual manner. Okay. Now, the next question. Next question is the based on the assumption on Rankine theory. The soil mass is stratified, submerged, homogeneous, or all of the above mentioned. So what are the assumptions? Whether on the basis of assumption, what we will answer? Whether the soil mass is stratified, submerged, homogeneous, or all of our means it is stratified, submerged, or homogeneous. But in my point of time, the solution for this question is C because they never say that this theory is applicable for stratified soil only. Neither they have told that it should be in the submerged conditions. So the homogeneous is the only assumption, homogeneous and isotropic is the only assumption taken by the runtime for his proposing his theory. Okay. So the explanation is according to the assumption of the runtime theory, the soil mass is semi-infinite, homogeneous, dry, and cohesionless. So it will be very much clear from this problem. Okay. Now, which of the following cases of the cohesion less backfill in the Rankine theory is considered? So our options are submerged backfill, moist backfill with no surcharge, backfill with sloping surface, or all of the above. So read the question again. Which of the following cases of cohesion less backfill in Rankine theory is considered the submerged backfill, moist backfill with no surcharge, backfill with sloping surface, or all of above. So, in my point of view, the answer will be D, that is all of above. So, read the explanation for this before moving ahead. So, the explanation tell us in a Rankine theory, in the following cases of the cohesionless backfill is considered. And what are those cases? Those cases are dry or moist backfill with no surcharge, submerged backfill, backfill with the sloping surface, and the inclined back and the surcharge. So this thing will be very clear in everyone's mind. What over here? Now, the factor that is responsible for the inclination of the resultant pressure to the retaining wall is responsible for the inclination of the resultant pressure for the retaining wall is. So, what is that factor? Whether the friction force? Yes or no? Surcharge, earth pressure, or weight of the wall. So this is very clear. The answer is A, that is the friction force only, because due to that only the inclination from the resultant pressure of the retaining wall takes place. We will read the explanation. So the explanation is the retaining wall are constructed on a masonry or concrete due to which the friction force develop. The existence of friction makes the resultant pressure inclined to the wall at an angle that approaches the frictional angle between the soil and the wall. So this thing is become clear for you at now. Now the next problem is if okay. Okay, this question is if the sand filled behind the retaining wall, basically the backfill, with the saturated water, with water, then the possible lateral pressure is the lateral pressure due to the submerged weight and the lateral pressure due to water. Lateral pressure due to retaining wall, none of the mentioned above, or all the mentioned above. So over here, my answer will be going to be the lateral pressure due to the submerged weight and the lateral pressure due to water, because the water has been put over their entire surface, though that is in the submerged condition, and the water is also there. So we will add that as well, because we will solve those problems again and again in a greater extent, so we will get a better understanding of those facts. Now, the explanation has been given over here. And the detail. So, this explanation which I have write, the lateral earth pressure is made up to two components of the weighted soil in back of the retaining wall, the lateral pressure due to the submerged weight, gamma of the soil and the lateral pressure due to water. So this is the answer only. So the option A will be the going to be correct. Now the earth pressure at rest exerted on the retaining wall, retaining structure can be calculated using the theory of plasticity, theory of elasticity, Mohr theory of rupture, or none of the mentioned above. So giving the answer of this problem is not very difficult, and it will be going to be the theory of elasticity. So, the earth pressure at rest resultant on the retaining structure can be calculated using the theory of elasticity. We will go with the explanation. The explanation says that the earth pressure at rest exerted on the back of the rigid underlying retaining structure can be calculated using the theory of elasticity only. What I have told earlier, that has been written over here. Okay. Now the next problem has been coming. So we will see this problem. Surely we will see. Okay. The problem say the value of K naught, coefficient of earth pressure at rest for the loose sand is. So we have seen a table. We have drawn the one section in a slide. Over there we have a loose sand, dense sand, and different type of soil condition has been given. For that the Poisson ratio has been represented. If we know the value of Poisson ratio from that table, we will answer this problem. But at this point of time, I will tell you for the loose sand the value of K naught is going to be 0.4. But when you go across these slides which I have drawn today, you will easily understood that what will be the value of K naught. Okay. Now, the next problem is the expression of K naught has been given by Jackie. So, Jackie has given in the expression in 1944 for the Earth's pressure at rest condition, and that is K naught equal to 1 minus sine phi. And so, the solution for our question is option number A only. And I don't need, I will explain this because this has been came three times in our slides. If you are there, you will easily understood. Okay, so the option A is the correct answer. It has been given in 1944, exactly what I have remembered. Okay, now this expression has been given later. Specifically, earlier we have the interrelation k naught is equal to mu by 1 minus mu. Afterward, the different researchers came and proposed the simple interrelation. There is interrelation also over there in the term of plasticity index. If the plasticity index has been known, we are able to easily in this property is known. We are able to calculate the value of coefficient of earth pressure at rest condition. So you need to discuss those things. You need to understood those things in a good manner in order to go ahead with the problem which we are dealing over here. Okay, I think so. Up to this, there will be no problem. So we will move to the next problem. So the next question is very good. And this question say what will be the coefficient of earth pressure at rest for the rigid retaining wall if the backfill consists of cohesionless soil having phi equal to 26 degree. So it is talking about the earth pressure at rest coefficient. So we know 1 minus sine phi will be the answer. So you can do in your calculator 1 minus sine 26 and the solution will be going to be option number C. So you can see over here in explanation we had used the interrelation proposed by Jackie as k naught equal to 1 minus sine phi and k naught equal to 1 minus sine 26 is k naught equal to 1 minus 0.4383. So our answer will be going to be 0.5616. So the option number C will be the correct answer. Okay. Up to this, it will be okay. I am not marking any point in this slide. So when you go across, you can take the printout of this or any which way, and you can cover the answers and you can go with the problems. Okay, some more problems are there for you, and these are the very easy problem, very small problems. So you can answer in a very little time, and we will wind up the session afterwards because there is approximately 5 to 7 problems Afterward, we will wind up into this. Okay. So the coefficient of active earth pressure is blank, then the coefficient of passive earth pressure. So what will be the answer? The coefficient of active earth pressure will be less than, more than, or less than, greater than, equal to, or insufficient. But we already know, if you have gone across, if you take any angle phi and you calculate 1 minus sine phi by 1 plus sine phi. So you already always get the value less than 1. But if you calculate 1 plus sine phi by 1 minus sine phi, basically k is 1 by kp and kp is 1 by k. Hence, if the value of k is less than 1, the value of kp is going to be greater than 1. Hence, in that case, the coefficient of active earth pressure is always less than the that of the coefficient of passive earth pressure. So the answer for this problem is going to be option number A. Over here, the coefficient of active earth pressure is the less than coefficient of passive earth pressure, and that's what I have mentioned at initial points 1. So the coefficient of active earth pressure is less than the coefficient of passive earth pressure, and the coefficient of active earth pressure is also less than the coefficient of earth pressure at rest. Okay, the additional condition was answer also provided that the earth pressure at rest is also have a more value than the coefficient of earth pressure in the active state. You can take any example and calculate. So you can test the solution by yourself as well. That what I am communicating with you, that will be correct. You will get the guarantee of that. Okay. Now, the second problem is the coefficient of earth pressure at rest is less than the coefficient of active earth pressure. Specifically, in the previous problem only, we have answered the solution of this problem. So, the coefficient of active or coefficient of earth pressure is at rest is greater than the coefficient of active earth pressure. So, the solution of this problem is going to be the option number B. This is a very simple problem which I have put over here. So you can see the option number B is the correct answer. The coefficient of earth pressure at rest is greater than the coefficient of active earth pressure. But the coefficient of earth pressure at rest is less than the coefficient of passive earth pressure. This has been understood from the previous problem. Now, the next problem is for the earth pressure at rest, there will be no vertical stress, no shear stress, no horizontal stress, or the both horizontal and vertical stress. So the earth pressure at rest will does not have any shear stress, because we always talk about the earth pressure coefficient as sigma h by sigma v. The shear consideration doesn't take come in our picture at any point of time. So this will be also very much clear for one and all. I think so. I think so. There is no need to worry about those aspects. Okay. Now we will move for next problem. Over here, the lateral earth pressure at rest conditions with respect to Poisson ratio has been given. So we already know the K naught equal to sigma h by sigma v, and the value of sigma h by sigma v need to be mu by 1 minus mu. So you can see over here, the option number C will be going to be the correct answer. Uh, and how it will be going to be, I will write it over here because the solution provided, but maybe these things may not be clear to you. So the option number C in the sigma h, I will take common, and I will 1 minus mu equal to mu into sigma p, mu into sigma v. Okay, so sigma h by sigma v, sigma h by sigma v will be going to be mu by 1 minus mu. The solution of the printed here may be not clear for you, that's why I am writing this. But this is the most basic things, you will understand this. Okay, so I think so clear. Okay, now I will go for the next problem. The next problem is the coefficient of earth pressure at rest condition is given as. So we know this value as mu by 1 minus mu. So our correct answer will be going to be option number A in this case. So this is our correct answer. A. Okay, this thing will be clear for everyone, I think so. Okay, this will be the correct answer. Okay. For this problem, the pressure distribution diagram for the Earth's pressure at rest condition will be the circular, triangular, rectangular, or square. So this is very clear. This will be going to be triangular only. So this is our answer. This is will be going to be our answer for this problem. Now, the next will be the coefficient of earth pressure at rest is represented as the Jackie, that is 1 minus sin phi. It has been asked many times. So, I think so. This will be clear for one and all. This is our solution. See, the coefficient of earth pressure at rest also computed by Jackie as this, and it is also represented in the term of plasticity index. There is integration already given to you. Now, this will be going to be the last problem. So, for the cohesionless soil, the angle of internal friction is 45 degree. Find the value of K naught. For the cohesionless soil, the angle of internal friction is 45 degrees. Find the value of K naught. So, we already know as the value 1 minus sin phi. So, that has been calculated. 0.293 will be going to be answer. So, solve this problem with your calculator and write the answer. Okay, okay. We have one more problem. Let me see how many problems left with us. Okay, very, very less number of problems are left. So I'll cover that. Okay. So backfill of the retaining wall consists of gamma as 19 kilonewton per meter cube and 6 meter high. Find the total earth pressure per meter length. Given the coefficient of earth pressure as 0.5. So 1 by 2 k gamma h square is applicable. See 1 by 2 k gamma h square. The answer will be this. Okay. And this thing has been represented in the slides 1 by 2 k gamma h square. So this is h and the gamma is there already and k value is this. So you when we solve this you will get the answer as 171. So solve with your hand. There is no problem with that. Now if there is another question, if the value of k naught as 0.4, find the value of mu. So you use the relation same way. K naught equal to mu by 1 minus mu, like 0. Mu by 1 minus mu, and you will solve this problem and get the solution. Okay, this is a very easy problem, simple problem. Take it 0.4 and then equal to mu by 1 minus mu, and solve this problem. You will get the value as 0.286. Simple problem. 1 by mu minus 1 equal to 1 by zero point 0.4. This imply mu is equal to 0.286. Okay, clear? Now the in problem mu equal to 0.3, find the value of k naught. So the interrelation is already there in the last slide. Solve this problem. The answer will be going to be 0.429. Okay, the last problem is like a vacuum of returning wall gamma is 19, and this is all this problem already solved. So this solution has been given. Okay, this is the foundation is being interesting question. Okay, so up to this only the content are today. So the today we have understood the Earth space rest condition and time theory. We already showed the Coulomb-based theory. We have understood the Earth pressure at rest condition, Earth pressure in active state, Earth pressure in passive state, and many more aspects which could be applicable. We have solved some of the problems. So you need to go across those problems in order to get a better understanding of the topic. Apart from that, I will suggest to write with your hand what is Einstein theory, what is the assumption of Einstein theory, what is Coulomb theory, what are the assumptions of Coulomb theory, what are the limitation of Einstein theory, what are the assumptions which could be turned into limitation by in your own mind. They don't need to go across with the textbook for writing those things. What you have understood with the today discussion, write with your own word and solve some problem on a today topic. Very simple problems I have discussed in the end, but those problems are very easy. Try to solve some problems from the textbook, and afterward, we will discuss some very good problem in the next class. The references which I will use for the today class discussion is the following, and up to that only in the today sessions. With this, I will conclude the today session. Thank you everyone for joining. We will meet again in the next lecture. This is the seventh week session. We will meet in the next session that will be going to be the eighth week. Thank you everyone for joining. With this, I will end the conclude the today's session. Okay.